All right, thank you. So I'm going to talk about some work that my graduate student Zheng Ho Li has done looking at ERCOT data. We all remember, a lot of us remember Winter Storm Uri, February 2021, what we're talking about this session, and it was really unpleasant for anybody that lived through it. And it really got me thinking about how did we get in this situation. So we started looking at ERCOT's forecast. So if you don't know what ERCOT is, the Electric Reliability Council of Texas, they run the Texas grid, which supplies about 80% of Texans' electricity. And as part of this, they make seasonal forecasts. And so we started looking at the seasonal forecasts they make. Now, one thing that is true about that is they only use historical data. And they only use historical data over about the past 2 decades. And so we wanted to look at what were the implications of that. Is that a good way to do it? The answer is no. And what does this mean about the forecasts themselves? All right, so the first thing we had to do is we had to create a model for power versus temperature. And so ERCOT provides hourly power demand, and we calculate daily average, and then we get ERA 5 temperatures, and we create a Texas average, a population-weighted Texas average temperature. And you can see that the data, this is 1997, the data are reasonably well constrained in this space. And then what we do is we do this basically for every year. So here are 2 years, 1997 and 2009. And so we do this, again, we do this separately for every year. And then we can put them all together, and you end up with something that looks like this. You see 1997 is the bottom one, then 2009 is the middle one, and 2020 is the top one. And so the curves move up in time. And that's basically due to non-climate factors. Basically, the population of Texas is increasing. So at any temperature, demand is going to increase. And then the shape changes a little bit. It becomes a little bit more convex. And again, that's also related to temperature. So we can parameterize the demand in terms of 2 variables. One is the year, and the year tells us kind of how high this curve is. And then the second variable is temperature, and that tells us where along the curve we are. So with these 2 variables, if you tell me the Texas average temperature in the year, I can tell you what the daily average demand is going to be on that day. And it works. And we have to do 2 more things. This relation gives us the daily average temperature, and then we need to we need to convert the daily average to a maximum power in that day. We do that with a linear regression using the ERCOT data because they give us hourly data. So we can regress daily average versus the daily maximum. And then we lastly do, and this is the most important quantity we want to calculate the seasonal maximum power. So that's the maximum daily average of the entire season, because that's what ERCOT cares about. If they can satisfy the maximum of the entire season, then they're happy, because they can obviously satisfy all of the ones less than that. And this method, this way of predicting temperatures, works quite well. So this plot shows the seasonal maximum power against year, and the black line is the ERCOT data. So we went through ERCOT, we found the hour of maximum power, and then we took our regression, we took ERA 5 data, and we predicted it. And you can see that we can predict the maximum power in any year given the temperatures. And you also notice that our prediction does poorly in the last year, and that's the blackout. The demand was over 80 gigawatts, but ERCOT could only supply 70 gigawatts. And that was actually, at the height of the blackout, they actually supplied a lot less. That was a few days when the temperatures had actually gone up a bit. But that's essentially the blackout, that the fact that our model doesn't work in that year. All right, now ERCOT, prior to the 2021, the blackout season, they made an estimate. This is like November of 2020. They said the maximum power we're going to see is 67 gigawatts. And they base that on 2011 temperatures. Remember, what they use are historical temperatures. And you can kind of see it's not a very good estimate because, I mean, 2018 was almost as high. And so we should have been very suspicious of their, what they call it the extreme scenario, their extreme scenario. Let me show you a quote. This is a quote that Texas Monthly did with Bill Magnus, who is the CEO of ERCOT. He got fired right after this. This is right after the cold event. And he said, we don't have any climate specialists on staff. So let me just begin by saying it's a weird way to phrase that. It's a $200 million organization. Their annual budget's $200 million. They can afford to hire a climate person if they wanted to. So that's a choice, that they don't have any climate person on staff. And he said, most of what we do is empirical. Most of it is, what's the most severe weather event we've seen that we need to be prepared for? That's 2011. So that's how they calculated their extreme event. That's what was, at least as of this week, pretty shocking about what we saw. Obviously, February 2021 is going to be a new marker for what we can see, and it will have to be worked into our models in the future. So we will come back to that, okay? But again, what they're doing is they're not using any climate modeling tools. They're not using the newest, most modern tools. They're essentially just saying, let's look at the last 15 years' data, and that's going to tell us what we need to face. And that obviously didn't work in 2021. All right, so what we're going to do is we're going to use a model ensemble. So we're using the CESM large ensemble, 39 members. It's a climate model that's run with identical forcing, identical model. You just change the initial conditions. And so it gives you an idea of what variability is. Now, we do apply a very small bias correction. You can ask me about that if you want. And what we do is we're going to use 2060 to 2025 DJF temperatures. And that's because those are pretty close to 2021. There's not a huge difference. There's not a big trend over this period. And then we're going to use 2021 non-climate factors. Remember, that's the height of the curve. And so we're going to get 390 simulations of DJF 2021. Then we're going to use our model to predict the seasonal maximum power from these 390. So while ERCOT has 15 years of data, we have 390 model simulations. So we can draw the PDF much better than ERCOT can. Because, if you have a PDF, you just take 15 samples. Who knows what your sample of the PDF is going to look like? That's essentially what they're doing. So let me show you some of the results. Let me begin by just giving you two numbers. So this is gigawatt. This is seasonal maximum power in gigawatts. And this is a probability. This line right here is ERCOT's peak. It's the extreme peak load scenario. And this line right here is what ERCOT said their max available power is, 83 gigawatts. And they said our extreme scenario is 67 gigawatts. So, the politicians love this. We have plenty of slack. Look, we've got, 17 gigawatts. Lots of things can go wrong. We still have extra power. So now when we take our CESM model and we predict seasonal maximum power, this is what it looks like. And so you can immediately see that their extreme scenario is not very extreme. And in fact, we predict there's a 19% chance that power demand will exceed what they call the extreme scenario. And in fact, there is a 1.5% chance that it will exceed total available power. So about 1.5% of the time, you're going to have demand more than the total available power, and about 20% of the time, you're going to exceed their base case. Now, so using a limited historical record does not provide a robust estimate of what power actually could be. And so I started looking at 2021, and in 2021, we estimate the demand was about 82 gigawatts, which is within a gigawatt of what the best case available supply is. What it tells you is if anything goes wrong with the supply, you're going to be short of supply. And indeed, things went wrong. The natural gas system imploded. Lots of other things went wrong in addition to that. And so we had the really large blackout. But during the summer of 2021, I started thinking, I can't wait to see ERCOT's prediction for winter of 2022, because as Bill Magnus said, you've got to include 2021. You have a more extreme year, so of course you've got to include it in the estimate. And I was really excited to see what they were going to say, and they were late. Like, you know, they usually put them out in early November, and it was late November, and I was on Twitter, people were like, where's their SARA, their seasonal adequacy resource assessment, their forecast? And they said, we don't know. And then they finally dropped it on a Friday afternoon, and they're still using 2011 temperatures as their extreme scenario. And so I talked, actually I have some contacts, I talked to them, and they said that 2021 DJF was too extreme to be used. And as Dr. NZ showed, it was, you know, depending on how you calculate it, it was a 1 in 50, 1 in 100 year event. But I mean, it really begs the question of how you do this kind of risk assessment. And they told me that their extreme scenario is actually a 90th percentile, which is not at all communicated to the community. No one has any idea that their extreme scenario, and that's about right. I think their estimate of about 90th, maybe it's 80th percentile, 85th percentile, 90%, but nobody has any idea that's right. You look at the extreme case, you think, well, that's the case we're never going to exceed. But in fact, we're going to exceed that once every 10 or 15 years. And so, you know, this, I think it's very convenient for them to do this because, remember, ERCOT is a political organization at some level, or it's run by people appointed by the governor, and ERCOT does not want to say we don't have enough power. And so this is very convenient for them. And I'm happy to talk with people offline more about my feelings about that. But I think they do a poor job. It's all to summarize. You know, ERCOT seasonal forecasts use historical data, and it means they're underestimating the impact of climate variability. And their extreme scenario is not extreme, okay? And so this is, and people don't understand that. We don't have any slack on the ERCOT grid. We don't have enough power. If anything goes wrong and you have an extreme event, you're going to be short of supply. And they really should use modern tools like climate models. And I asked them about that, and they just, you know, we were on a Zoom call, and it was like, you know, they immediately disconnected when I told them to use climate models. You know, they really don't want to do that, and I think that's political. You know, they feel like they can't talk about climate models in this. And they should also, I didn't put it up there, but they should also make their forecast model public, which they don't do. Anyway, we have a paper that describes this in Weather Climate Society. It's in press. If you are interested, talk to me and I can give you, or email me. Anyway, thank you.